Welcome to PV Online Physics. Today we're going to start an introduction into acceleration. Now you just spent some time in Unit 1 learning about constant velocity. And you'll notice the diagram on the left here. This is a nice illustration of constant velocity because you can see at every second interval, whoops, that wasn't quite what I was looking for, but at every second interval, how far does our car go? And you'll see that in the first second it goes 10 meters, in the second second it goes 10 meters, third second 10 meters, and so on and so on. All right, so that was constant velocity, and it shows up on our graph by this nice diagonal line. And remember that the slope of the position time graph equaled your velocity. Okay, so it equaled the velocity of the car. Now, in this case, the slope would equal 10 meters per second since every second the car went 10 meters. Now, over on the right, this is showing accelerated motion, and you've all experienced this when you first get in your car and you press down on the gas, and all of a sudden you start going faster and faster and faster. Well, one of the consequences of that is that each successive second, the distance you travel will go farther. So you'll notice that in the first second, the car went 2 meters, but in the next second, it went 6 meters, then 10, then, so what is that, 14, and so on, and then 18. So you can see that the distance each successive second got bigger and bigger. And now that's shown by the position time graph. And the distinctive characteristic you want to look at is the curve. The fact that it's curving is telling you that the slope is changing. So since the slope is changing, that means my velocity is changing. The slope is still going to give us the velocity. It's just our slope is changing because our velocity is changing. Now down at the bottom here, you can see that now I have a velocity time graph. And with the velocity time graph, I now get a diagonal line. And I'm getting a diagonal line because my velocity keeps increasing, that each successive second it gets bigger and bigger. So if I wanted to take a look at what my acceleration was, I could simply calculate the slope. The slope of a velocity time graph equals the acceleration. So now for this example, I'm going to run out of space, sorry. So for this example, let's take a look at these 2 points. We'll look here, whoops, I'll look right here. And you know what, let's just go 0, 0. So the acceleration then is going to equal the change in velocity divided by the change in time. Now it's easy to make your initial time 0 because it'll make the math easier. So I'm going to look at my final velocity, and my final velocity was 8 meters per second minus my initial velocity, my initial velocity, which we said was 0, divided by the time. And the final time was 2 seconds minus the initial time, which was 0. That's going to leave me then with an acceleration. Let's go over here. My acceleration then will be 4 meters per second. Or we sometimes call that 4 meters per second squared. Now notice that second shows up twice because we're looking at the rate of change of velocity. Velocity itself is a rate, so now we're really looking at a rate of a rate. All right, so now you should be able to take a look at some of the homework problems and get started. Good luck.